The point of the second video part here is to investigate ways to solve systems of equations. This is the same example that we did in the first video lesson, and now we're going to talk about how to solve it. Now I obviously know you can solve this one using, I'll call this traditional algebra. In this case, traditional algebra, we can see that A is 3 and then plug in the 3 and solve using elimination, so on and so forth. That's pretty easy to do here. But I'm going to use this example 1 to also talk about a process called Rowechelon. So it's Rowechelon form. The method is Gauss elimination. So that's new. That's a linear algebra type of process. Number 3, we're going to look at a matrix. Now there's matrix by hand and then there's matrix by calculator. Finally, number 4, one you should be familiar with is Kramers Rule. Kramers Rule deals with determinants. Assuming that you know traditional algebra, I'm going to go to Rowechelon form. What we're going to do here is look at the coefficients. Here the coefficients for A is 1, coefficient for B is 1, coefficient for C is 1, and that equals 4. Then we have 2, -1, 3, 13, and then we have -3, 0 for the B, 0 for the C, and -9. The ultimate goal in this is to have something that looks like this: 1, 0, 0 going down, 0, 1, 0, 0, 0, 1, and then you have new values here, and these new values will be your solutions to A, B, and C respectively. Now, to do this, actually, I'm going to make this be the first line. So I have -3, 0, 0, -9, and then I'm going to continue with 1, 1, 1, 4, and then finally 2, -1, 3, 13. The reason for that is when you have your zeros already, you don't want to translate them into any value other than 0. So in effort for me to get a 1, 0, 0 somewhere here, I need to put this line first. Now to get this -3 to be a 1, I divide by -3. And that leaves me with 1, 0, 0, dividing the -9 by -3 gives me a 3. And then I continue as follows. Okay, we're ready for the next step. The next step, once I have this 1 fixed, the next step is to get these values here beneath that 1 to become a 0. So what do I need to do here? In order to make this 0, I'm going to multiply this value in this row by -1 and add it to the second row. So I have the 1, 0, 0, 3. Now if I take this times -1 and add it to the second row, I get a 0. And I will continue that process. Multiply this by -1, add it to the second row, I have a 1. Take this by -1, add it to the second row, I still have a 1. Take this by -1, add it to the second row, and that turns out to be 1 also, because -3 plus a 4 is a positive 1. Okay, now I'm going to skip to here. So if I multiply the top row by -2 and add it to the bottom row, I'm going to get a 0, which is what I wanted. Then I'm going to get a -1, I'm going to get a 3, and then I'm going to take this number here by -2 and add it to the 13, and that's going to give me a 7. A 7. Good news is, on the second line, 0, 1, 1, 1, the second row that is, this value is already a 1, so I'm in good shape. And this value above it is already a 0, so I'm in good shape. So the manipulation that needs to occur is taking and getting this -1 here to become a 0. So how do I do that? Well, if I take the second row, multiply it by a 1, and add it to the third row, then I'm going to get a 0. 1 times a 1 is 1. Add it to the second row, I get that 0 that I need. And then the 1 plus a 3 is going to give me a 4. And then the 1 plus a 7 is going to give me an 8. So we're in real good shape here. So you see that we've got to make this 4 a 1. So let me rewrite what we have. 1, 0, 0, 3, 0, 1, 1, 1. Now I want to make this row such that I have a 1 in this position. So I'm going to divide every element by a 4. 0, 0, 1, and 2. So we're not done yet, because this is successfully a 1, but I need all other entries in that column to be a 0. So 0, 0, 1, the 2. So what do I need to do to this row, and then adding it or subtracting it to the second so that I eliminate the 1? Hopefully you see it's multiply the third row by -1, add it to the second row. That'll give me a 0. 0 times a -1 gives me the plus the 1 gives me 1. 1 times a -1 added to this value is going to give me that 0. A -1 times the 2 will give me a -2. Add it to the 1, and that gives me a -1. No manipulation is needed for the first row because we already have a 0 in this entry here. And there we have it. We have the values A, B, and C. We're going to discuss Kramers Rule next. In Kramers Rule, we do something similar as the Rowechelon form. 1, 1, 1, 4. 2, -1, 3, 13. These are the coefficients. -3, 0, 0, -9. Like this. So I'm going to solve for one of them, just so you get the point. Let's suppose we're solving for A. We set up a determinant. D here will stand for the denominator, not for determinant. The denominator, we will look at a determinant 1, 1, 1, 2, -1, 3, 1, 0, 0. Now why did I make that 1, 0, 0? Because it just makes sense here, just like in the other form, to divide everything by -3. Okay, so there we have it. So this will become our denominator. Now you have to remember how to do a 3 by 3 determinant. So we take this value here, and in our mind cross these out. So this is going to equal 1 times a new determinant, -1, 3, 0, 0. Next, I have this value of a 1. And if you recall, it goes plus, minus, or as is opposite. And so from the blue, I cross out this way and down, which leaves me with a determinant of 2, 3, 1, and 0. And then finally, we look at this value here, and that's going to be, in this case, a plus 1, plus, minus, plus, and crossing out here and down, I have a 2, negative 1, 1, 0. And then to actually solve these determinants, 2 by 2, that's easy. It's bump times bump minus bump times bump. I like to say the bumps because it helps me remember. Bump, bump, bump times bump. So negative 1 times 0 is 0. Minus 3 times 0, which is 0. So we have a 1 and a 0. Again, that's negative 1 times 0 minus 3 times 0, which equals 0. Now let's take a look at the blue. So I have a negative. I've got to figure out the determinant. 2 times 0 is 0 minus a 3 times 1. That's going to give us a negative 3. And then finally for green, I have a plus. 2 times 0 is 0 minus a negative 1, which becomes a positive 1. If I add those up, I get a 4. Yep, I get a 4. So that's going to be the denominator. Now that's going to be true whether I'm solving for A, B, or C. The denominator is going to equal 4. So now let's take a look at the numerator. But it's the numerator for A because I'm solving for A, and I would do the similar process for B and C. So I'm trying to find the numerator for the A value. So what do? I'm going to come back to this original, and I'm solving for A. So A is associated with the first column here. So what I do is I replace the first column with the solution coefficients. These are the solution coefficients, and they replace the first column because I'm solving for A. And now I have a new 3 by 3 determinant. So I have 4 times negative 1, 3, 0, 0 determinant minus 1 times 13, 3, 3, 0. Now I'm fouling this up because this should be, no, I'm not. This is good. Finally, plus 1, 13, 3, 3. Oh, crud. Now I messed it up. This is 13. This is a negative 1. This is a 3. And this would again be 0. There we go. Okay, so now we have 4. We'll do our bump times bump. 0 minus 0 minus 1. 0 minus 9 is negative 9. Plus 1 times 0 minus a negative 3, which becomes positive 3. Add those together and you get a 12. Alright, so I'm going to sneak this in somewhere. So for the value of A, it's going to be the numerator for A over the denominator, which is going to be 12 over 4, which equals 3. And that would successfully solve for A. You would do a similar process for B and C, except you would over here replace the solution with B and then the solution with C, finding the 3 by 3 determinant there.
Now let's solve the system of equations using a matrix method. In general, we think of the matrix method as some matrix A, which will be a matrix of coefficients, times a variable matrix equals a matrix of constants or sometimes said solutions. Now in general, if I take a matrix inverse of A times matrix A, that'll give me the identity matrix, which will then isolate X, but whatever I do to one side, I must do to the other side, so I will multiply matrix inverse to matrix B, and I must do it in this order as matrix multiplication does not follow the commutative property. And so now here the matrix X, the A, the B, and the C, the thing we're trying to find, is solved by finding the inverse of matrix A times matrix B. So what is matrix A? Well, matrix A, not to be confused with the A we see up here, matrix A is a matrix of the coefficients. So the coefficient of A is 1, the coefficient of B is 1, the coefficient of C is also 1. The next line reads coefficients 2, negative 1, 3, and the final line is 1, 0 for the B, 0 for the C. The matrix of variables, the variables being A, B, and C as seen above. Now you need a little knowledge of matrix multiplication to see that these here get multiplied by these, which would yield this equation. And this, of course, would equal this matrix of constants. And I just realized that this should be a 4, not a 14. So 4, 13, and 3. So now we have matrix A, and the goal now is to find matrix A inverse. And A inverse is going to be 1 over the determinant of A, which we found in the last section, times the adjugate matrix of A. And that's where our work is going to be here. The adjugate matrix involves another term, which here is called the transpose of matrix A. Now the transpose of matrix A is fairly easy. If we take a row, or in this case, I'm sorry, if we take a column, we turn it into the row. So first column becomes first row, the second column becomes the second row, and finally the third column becomes the third row. That's the transpose. Now the adjugate matrix of A will be a matrix of cofactors of the transpose matrix. So what does that mean? Well, first let's take a look at the coefficients. They're going to follow this keep, change, keep, change, keep, change, keep, change, keep. Keeping the sign, changing the sign. Now the cofactors, like when determining a coefficient, entail some minor matrix. So if I'm trying to find the first cofactor here, I will eliminate this way and find the determinant of the resulting minor matrix, and I will keep its sign. In this case, negative 1 times 0 is 0, minus 0 times 3 is also 0, and that's a 0. We don't have to worry about keeping that sign, but if it were positive, it would stay positive. If it was negative, it would stay negative. For the next entry, also pretty boring, 0 minus 0 gives us 0. And in this final entry of the first row, be 1 times 3, which is 3, minus a negative 1, and that comes out to be 4, and I will keep the sign of the 4, and it ends like that. Let's do this next one, and then you'll see the pattern. So this is going to be 2 times 0 is 0, minus a 3, so it's a negative 3, but I have to change the sign, so that comes out to be positive 3. And this pattern continues to create the entire adjugate matrix. And now the inverse of matrix A is 1 over the determinant. We found that the determinant was 4 times this now adjugate matrix rather. And if we multiply that out, we simply multiply the 1/4 times all of the components, resulting in this matrix here. Our final step here is to find our matrix X, or matrix ABC, and that's going to be the inverse, which we calculated here. And we're going to multiply that by the matrix of solutions or constants, a little bit of matrix multiplication, and we get 0 plus 0 plus 3. Then we're going to get 3 minus 13/4 minus 3/4, and then the last entry is going to be 1 plus 13/4 minus 9/4. Doing that arithmetic, we get 3, -1, 2, which is exactly what we got using the previous method. This is not going to be the method that we focus on. I just wanted to expose you to it.
We will finish this video with a big old row echelon of example 3. Actually, I lied. Let's do this one together, and then we'll finish with a nasty one, which is kind of fun. Anyway, let's do it. So we're going to do row echelon. This is the one that I'm holding you responsible for knowing, so let's see if we can't do this. So first off, we have 1, 2, 0 for the C, and 1. That's representative of that first line. The second one would be 0, -1, 2, -1, and finally 4, 0, -1, -21. So let's see if you can remember how this works. Here's a 1. It's already a 1, so that's desirable. We have to make this 0, and it already is, so I'm pretty happy about that. So I have to make this, I'm going to affect this row because I have to make this a 0. So I'm going to multiply my top row by -4, add it to the third row, 0. By -4, add it, -8. Times -4, add it, times -4, add it. Okay. Done. Next, I want this to be 0, 1, -2, +1, so that this becomes a 1. Alright, let's do this now. We need to make this a 0. So I'm going to multiply this by a -2 and times it to the first. This times -2 to that. This times a -2 to the 2. This times a -2, which is a 4, to that is a 4. That becomes a -1. Okay, so what do I have to do here? I have to multiply this row, if you can see my cursor, this by 8, added to the third, by 8, added to the third, by 8, added to the third, by 8, added to the third. Okie dokie. So we have, now I want this to be 0, 0, 1. I can get that by dividing by -17. And what can I do? Some manipulation here. So 0, 1. So if I multiply by a -2 and add it, by a -2 and add it. Okay, I'm looking at here, and what do I need to do to this? So by a -4 add it, by a -4 add it, by a -4 add it, by a -4 add it. And what am I missing? Sorry, this should be a 1. Okay, so that then tells us that A is -5, B is 3, and C is 1. The same result we found. The one we're going to finish with now is going to be example 2, row echelon. Let's see if we can't grind that one out. So here we go. The example number 2 from the previous video led us to the system of equations, which I have translated into this special row echelon form. And we're going to begin. So this is a 1, 1, 0, 0, 3. I would encourage you to try it on your own before watching this. Then these need all be zeros. I'm going to try to do this in one step. This is a 0. Okay, so I'm multiplying this by -6 and then adding it to this row. Actually multiplying it by +6, adding it to that row. So then this becomes a 3, this becomes a 1, 0, 0. For the next one, it's my -12 add, so 0, -12, -1, 1, -7. And for the last one, it's by +8 add, so it's going to be 0, 12, -2, 1, 20. Okay, I'm going to take this, I need this to be a 1, so 0, 1, 1/3, 0, and 0. Multiplied everything, yes, multiplied by a 1/3. And this needs to be a 0, so what do I need to do? I need to multiply by negative, add, so I get 1, 0, -1/3, 0, 3, 0, 0, 3, 1, -7, 0, 0, -6, 1, 20. Okay, so moving along, I'm going to start just writing down some results of this. So I just turned this 3 into a 1, and that's all I did in this step. Next, I made my manipulations in order to get this echelon form, and then I'm going to write the next one now. You might want to press pause. Here we simplified for 1, and then second just divided by 3. And the last step here, we got rid of all these values, turning them into zeros using the method described in the video, and we have found our solution. A is 2, B is 1, C is -3, and D is 2, which would finalize the decomposition, which is the big picture here. The thing we really want to do is be able to decompose larger fractions.